Okay, so first of all, I'm going to create some comments. So here we have talked about it, that it is basically the no collision situation. So it is a simple insertion into the hash table. Anyways, we know for certain that it's going to be a collision. So collision when inserting with key, and I'm going to append the key here. Okay, and basically that's all. Maybe here I'm just going to say that considering the next item in linked list, and I'm going to append the hash item dot get value, and here I'm just going to print out that finally we have found the place to insert ... okay, whatsoever. So I would like to make sure, sorry for that, it's very important that because this hash function we have implemented is not that bad, it's going to generate different array indices for different keys. But we would like to test our application that how to handle collisions. How are we able to make sure that there's gonna be a collision? If the hash function is going to return, for example, the array index 1 for every single key, we just have to return 1. So this is how we're able to test it. It's not going to work fine in an application, but we just want to check that how it handles collisions. I'm going to instantiate a new hash table, and I would like to put, for example, with the key is equal to 1, the value is 10. Then I'm going to copy and paste it several times. Maybe I'm going to make some new line after every insertion. Okay, so we insert 100, then 1,000, then for example 10,000, where the keys are different. Okay, it doesn't matter because the hash function is going to return the array index 1, no matter of the keys. So let's see how it works. And yeah, basically it's true, because first we have to instantiate a hash table. So in the constructor, we just have to make sure that this hash table is equal to a new hash item, and we just have to have as many hash item as the table size. So that's all about it. I think that the null pointer exception is going to go away. Let's run it. And as you can see, it is approximately working fine. For inserting the first item, there cannot be a collision because this is the first item. So in the hash table, we just want to insert it and we generate an index. The generated index is 1. Okay, then we would like to insert that given item where the index is 1. It is empty, so we just have to insert it. No problem so far. What about inserting this one? As you can see, there's a collision, inserting with key 2. Why? Because our hash function is going to return 1, no matter of the keys. So basically, it's going to insert to the same array index. So it's going to be a collision because there's already the first item we have inserted. Okay, so basically we just insert it and we consider the next one and we set the next hash item accordingly. What about the third item? We would like to insert 1,000. It's going to be a collision. Then we are going to visit basically the second item we have inserted because this is the second item in the linked list. Okay. What about the fourth item, the 10,000? There's going to be a collision again. We have to consider the 100, then we have to consider the 1,000, and then we set the 10,000 to be the next item of the 1,000. So this is how we create a linked list. This is what we have been discussing in the theoretical section. Okay, let's see whether if I would like to get, for example, the hash table.get, I would like to get the value where the key is equal to . Let's run it. As you can see, there's the 10. Okay, it's working fine. What if I would like to get the value where the key is equal to 3, it should return 1000, yeah. What if I would like to get the value where the key is equal to 4? We should get 10,000. Let's check it. 10,000, okay. So let's check whether it's working fine if the hash function is not that clumsy. Okay, we would like to generate different array slots, array indices to different keys. Okay, so let's run this application. No collision, no collision, no collision, no collision. You may pose the question that, okay, why? Because our hash function is going to return different array indices to different keys. Basically, this is how a hash function works. This is why we came to the conclusion that we have to construct a hash function to be able to map keys into array slots. And as far as this application is concerned, it is perfect in the sense that there's no collision. Okay, if we would like to insert more than 10 items into the hash table, of course there's going to be a collision. So let's test it. Because the table size is 10, then if we insert more than 10 items, for example 11, I think it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10 and 11. So let's see whether it's going to work fine or not. We should get approximately, I'm not sure, it depends on the actual probability of what we are going to generate, but let's consider that we insert 10, then 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm not sure whether it's clear or not, but if we insert more than the size of the table, it's sure that there's going to be at least one collision. There may be several collisions, okay, I'm not sure how many collisions are going to be there, but it's 100% sure that there's going to be at least one collision. No collision, no collision, okay, basically there was just a single collision when inserting with key 11. Okay, we should anticipate this result because this hash function is just going to create indices 1, 2, 3, 4, 5, 6, 7 and so on. So there's going to be the collision for the last item. Okay, and basically we get the 100. Is it working fine? When it's 10, yeah, we should get 100. So it's working fine. This is how we construct a hash table. And that's the theory behind hash tables, that we have to construct a hash function, and this hash function is going to map keys to array indices. Thanks for watching.